In today's video, we are going to be evaluating a question on limit. And we'll be solving this question using limit by factorization. Now, before we go ahead to make use of this approach, the first and easiest method to always use to evaluate a limit is by direct substitution. So we are going to use the approach and see if we are able to get a result. If we are, excellent. If we are not, then we go ahead to look for other means to evaluate this limit. So using direct substitution, so I'm going to write using direct substitution. We have the limit is at 0, that will be exponential into bracket 2, 0. Exponential raised to the power 0 minus 1. So this is going to give me 2 times 0, that is exponential to the power of 0 minus 1 over exponential to the power of 0 minus 1. Exponential to the power of 0 is 1, so this will be 1 minus 1 over 1 minus 1. And this is giving me 0 over 0, which is indeterminate, meaning that I can't determine what the answer is. For a limit, we actually need the value. Hence, we go ahead to check if there are other methods that we can apply. And that is when you look thoroughly at your function. When you look at the numerator of your function, you check, is there a way I can simplify this to ensure that maybe another method might work? Now, if you look at this, I can write exponential raised to the power 2x minus 1 as exponential to the power of x all squared minus 1. So it means I can do something like this, that this can now be written as limit as x tends to 0, exponential raised to the power x all squared minus this 1. I can also express it as 1 squared. Of course, 1 times 1 is going to give me 1 over exponential to the power of x minus 1. Now, using difference of 2 squared, that is, if you remember, a squared minus b squared will give us a plus b, a minus b. Hence, I can say this will be limit as x tends to 0, exponential raised to the power x minus 1, exponential raised to the power x plus 1 over exponential raised to the power x minus 1. So this cancels this, and I am left with the limit at x tends to 0 of exponential raised to the power x plus 1. So I can now directly substitute in my value into this function, and this gives me exponential to the power of 0 plus 1. Exponential to the power of 0 is 1, so we have 1 plus 1, and that means the limit of this function as x approaches 0 is 2. And that is how you evaluate limit using your idea of factorization. So it's not all limit that I use direct substitution for. There are several other methods we can apply, and this is just one of it. I hope to see you in my next video where we look at other methods that we can use to evaluate limit. See you on the next one. Thank you.